In this video, we're going to talk about scientific notation. Scientific notation is a shorthand notation to write really big numbers or really small numbers. So when we talk about writing really big numbers, we're going to have positive exponents. So let's think about the number like 6320000000000. So this is a pretty big number, right? So this is millions, billions. So this is 6,320,000,000,000. And we have a lot of zeros. One way to write that is to express it in scientific notation. So with scientific notation, when we have something that's really large, really not large numbers are going to have positive exponents. I want you to remember that. So we're going to start wherever the decimal is. The natural decimal for this guy would be at the end, and we're going to move it to the left until there's just one number in front of the decimal. So I'm going to move this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. So the number of times you move it's going to be the exponent. So I'm going to write this, and I'm going to keep all those decimal places. This is 6.32. Well, if I can get my pen to write 6.32. And there's always going to be times 10 to some power. Because I moved that decimal 12 times, my power is going to be 12. So this is 6.32 times 10 to the 12. Let's do something that's really small. Let's say we're looking at something microscopic. And I've got 0.0000000245. Well, that's a lot of zeros in front of that number 2. This is something that's super small. Super small numbers are going to have negative exponents. That's how you know if it's a big number or a small number. Negative exponents are going to be small numbers. Positive exponents are going to be big numbers. So we're going to do the same thing. We're still going to move the decimal. We're starting here now on the left-hand side, and we're going to move that decimal 1, 2, 3, 4, 5, 6, 7, 8. I'm going to stop when I get one number in front. So this is 2.45 times 10. And then you're going to talk about how many times you move the decimal. We move the decimal 8 times. Because it's a super small number, it's going to be a negative 8. So it's always going to be some number times 10 to some power. And the power is going to be positive if it's negative. Positive exponent if it's really big. And a negative exponent if it's super small. So let's look at a few examples. Let's say we want to write the number 4,500 in scientific notation. The natural decimal here is at the end. So we're going to move that decimal 1, 2, 3 times. So this is going to be 4.5, okay, times 10. And we move that decimal 3 times. So we're going to use a positive exponent there. So we've got the next one. We have 638 million. So I'm going to recopy that number. We're going to move the decimal. Right now, the decimal is understood to be at the end. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8 times. So I'm going to get 6.38 times 10, and we move that decimal 8 times. So it's 6.38 times 10 to the 8th. There's my scientific notation. You may want to pause the video and try to write 72,000 in scientific notation. 72,000 is going to work the same way. We're going to start at the end. The decimal is understood to be at the end. We're going to move 1, 2, 3, 4 times. So this is going to be 7.2. And it's always going to be times 10 to some power. It's just you got to figure out how many times you move the decimal. We're moved it 4 times, so it's going to be 7.2 times 10 to the 4th. So now let's look at those super small numbers. Super small numbers, we're going to have negative exponents, so we got to keep that in mind. We have 0.00072. That decimal is at the very beginning. We're going to move 1, 2, 3, 4. You always move until there's one number in front of that decimal. And since this is a super small number, we're going to use a negative exponent. So we have 7.2 times 10 to the negative 4 as our scientific notation. The next one, we have 1, 2, 3, 4, 5, 6 zeros. So point and then 6 zeros, 3, 9, 1. So we're going to do the same thing. The decimal is over here on the left. 1, 2, 3, 4, 5, 6. We're moving 7 times. So it's going to be 3.91 times 10 to the negative 7. Okay, here's your try it on your own. We have 0.0056. Write that in scientific notation. 0.0056. We're going to move that decimal 1, 2, 3 times. So we're going to get 5.6 times 10 to the negative 3. So if we can take a number and put it in scientific notation, then we should be able to take it out of scientific notation also. So let's look at that first one. We have 3.2 times 10 to the 4. Okay, because this is a positive exponent, this is going to be a really big number, so it's going to be large. So that 4 just means we're going to move it 4 times, and since we want a big number, we have to move it to the right. So all those little loops we're going to fill in with zeros. So my answer here is going to be 32 with 3 zeros after it, which is 32,000. The next one, we have 7.05 times 10 to the 6th. So we're going to move the decimal 6 places. 1, 2, 3, 4, 5, 6. We're filling in with 4 zeros. So we have 705 and then 4 zeros. So there's my thousands. So this is 7,050,000. To try it, it's 9.1 times 10 to the 5. Take a minute, see if you can convert that to scientific notation. To standard form. So that positive 5 means we're going to have a big number. We're going to move that decimal places 5 times to the right. We're going to put in 4 zeros. That's called annexing a 0. So we're going to have 9-1 with 4 zeros. And then if I put my commas in, I always start at the end and go back 3. Every 3 I put a comma, so it's 910,000. So what about 5 times 10 to the negative 3? That negative 3, 5 times 10 to the negative 3, that negative 3 means that we're going to have a super small number. So I'm starting with the number 5. The decimal is understood to be after the 5. I'm moving 3 because I want something small. I have to move 3 to the left. 1, 2, 3. That's where my new decimal is going to go. Now it's going to be important to write this decimal. We're going to annex some zeros. So in standard form, that number is 0.005. The next one, we have 6.4 times 10 to the negative 5. We're going to move that decimal 5 times to the left. 1, 2, 3, 4, 5. put in our zeros. So our answer is going to be 0.000064. With decimals, we don't put commas in like we do with really big numbers. That last one, try it on your own. 2.3 times 10 to the negative 6. Take a minute, try it, come back, check your answer. So we have 2.3. The negative exponent tells me I need a really small number, so I'm going to move to the left. So I'm going to move that decimal left 6 times. 1, 2, 3, 4, 5, 6. Put in my zeros. So this is going to be points, and then 5 zeros, 2, 3. The next few problems are a mixed practice. This is where you should pause the video, try it, come back and check your answer. So with this one, we have 0.0000824. I want to write it in scientific notation. I'm going to move that decimal 3, 4, 5 times until I have one number in front. So it's 8.24 times 10. And I moved it 1, 2, 3, 4, 5 times. But because this was a super small number, it's going to be a negative 5 as that exponent. The next one is 6.03 times 10 to the 7th. So I'm going to write 6.03. I have a positive 7 as the exponent, which means this is going to be a really big number. So I'm going to move this to the right 7 times. 1, 2, 3, 4, 5, 6, 7. Put in my zeros. So my number is 603 with 5 zeros. And then I'm going to start at the end. For every 3, I'm going to put in that comma. So I have 60,300,000. The next one is 913 million. I want to write it in scientific notation. The decimal is understood to be at the end. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8 times. So remember, we want one number in front of that decimal. And since this is a super big number, I'm going to use a positive exponent. So it's 9.3 times 10 to the 8. And that last one, we have 4.5 times 10 to the negative 4. So they want us to write this in standard form. We're going to move that decimal to the left because that negative 4 exponent tells me this is a super small number. We're going to move it 4 times, put in our zeros. So our answer is 0.00045.